I'm Anil Kumar. Here are 4 questions for review of Chapter 2 regarding derivatives. You can take it as a test practice. Question number 1. The line y equals to 8x plus b is tangent to the curve y equals to 2x squared. Determine the point of tangency and the value of b. Second question is, determine the points where slope of the tangent to the given curve is horizontal and or undefined. 3 is, determine the equation of tangent to the graph of y equals to x squared minus 3x minus 2 times 7 minus 3x at 1, 8. Last question here is, at what point on the curve y equals to x to the power of 4 does the normal have slope of 16? I'd like you to pause the video, copy these questions, try them out, and then check with my solution. So let's solve them one by one. Very first question here is, the line y equals to 8x plus b is tangent to the given curve. So we are given line y equals to 8x plus b. Now from this equation, slope m of the line is 8. Now this line is tangent to the curve y equals to 2x squared. Now this line is tangent to y equals to 2x squared, right? Now what is the slope of any tangent on this curve? The slope will be derivative of this, which is 4x. Since the line is tangent to the curve, we can equate both slopes to be same, correct? So that is to say that slope 8 should be equal to slope 4x, correct? Same slope. And that can help us find the value of x. So 8 is equals to 4x, and that gives us 8 divided by 4 is x, which is 2. Since x is 2, we can find the y value also. So we know y equals to 2x squared, and since x is 2, we can write this as 2 times 2 square, which is 2 square is 4. 4 times 2 is 8. And therefore, we get the point of tangency, right? So that gives us the answer for first question, which is point of tangency. So we can write down here, point of tangency is the x value is 2 and the y value is 8. So that's the first part. Now second part of this question is, let's do it on the right side. Second part of the question is, find the value of b. So we know y equals to 8x plus b, and we know that the point which is common to both is 2, 8, right? 2, 8. Substituting this point, we get the value of b. So it is 8 equals to 8 times 2 plus b. So 8 minus 16 is b. So minus 8 is the value of b, right? So we get our answer, and our answer is point of tangency p is 2, 8, and the value of b is minus 8, correct? So that is how you can actually solve the very first question. So I hope it is absolutely clear. Let's now move on to the next question. The question here is, determine the points where slope of the tangent to the curve f of x equals to 2 times x to the power of 5 over 3 minus 5x to the power of 2 over 3 is horizontal or undefined. So we are given the function f of x as equals to 2 times x to the power of 5 over 3 minus 5 times x to the power of 2 over 3. So the derivative will give us the slope of tangent line, which is 2 times 5 over 3 x to the power of 5 over 3 minus 1, which is 2 over 3, right? Minus 5 times 2 over 3 times x to the power of 2 over 3 minus 1, which gives us minus 1 over 3, right? Now, we want this, let's rewrite this first, right? So let's rewrite this. So what do we get here? We get 10 over 3 as common factor. We can also factor out minus 1 over 3. So we get 10 over 3, and we can factor x to the power of minus 1 over 3. We get, if I do minus 1 over 3 minus, that means we get x here. And we already factored out all this, minus 1. Is it 0? So we could actually rewrite this as, because this is negative, so I'll take it in the denominator, okay? So let me rewrite this as 10 times x minus 1 divided by 3 times cube root of x. Correct? So that becomes the derivative for the function. Now the question is, when is it 0? The derivative is 0. And when is the derivative equal to undefined? So we are looking for now two cases. One is that the derivative is equals to 0. The other one is that the derivative is undefined. Right? Now derivative is 0 when numerator is 0. Perfect. So case 1, where we'll consider derivative equals to 0. Horizontal, that means. Is it okay? So that is when the numerator is 0. So let me equate numerator to 0. So we have 10 times x minus 1 equals to 0. And that gives us x is equals to 1. So at x equals to 1, we have a horizontal derivative. Now second part is, when is it undefined? So let's do part B, where f of x is undefined. Undefined means vertical tangent. Right? And you will get that undefined means denominator is 0. So that means cube root of x is equals to 0, right? 3 is a constant, that cannot be 0. And that implies that x is equals to 0. So we get 2 points. So first point, where it is horizontal, we can equate x equals to 1 and find the point. So we have f of 1 equals to, if I substitute 1 here, I get 2 times 1 minus 5 times 1, which is 2 minus 5 or minus 3. And if I substitute 0, what I get here is 0, 0, correct? So we know 2 points. It is 0 or horizontal at x equals to 1. So this point is 1 and minus 3. And the other point is the origin itself. So those are the points. Well, for some of you who are interested in this graph, it will look something like this. This is kind of like this. So we have a undefined slope at origin. It's kind of like this and like this, where this is horizontal at 1. Do you see that? This is the point x equals to 1. So I hope that gives you a complete picture of what we're trying to do. Is it okay? So at origin, we have undefined slope, and at 1, x equals to 1, we have horizontal slope. Correct? Now let's take up the next question. You must have observed that in all these questions, we're trying to find tangents and normals, their equations, or the point, right? But there is a variation, a twist in each and every question, so that you get the knowledge of finding different kinds of related questions solution. Now the question is, determine the equation of tangent to the graph at a given point. So to find the equation of tangent, we need slope. For slope, we need the derivative. In this particular case, we can apply the product rule. That means derivative of the first function, d dx of x squared minus 3x minus 2 times 7 minus 3x plus first function, which is x squared minus 3x minus 2 times derivative of second function, 7 minus 3x, right? So that gives us 2x minus 3 times 7 minus 3x plus here we have x squared minus 3x minus 2, derivative is minus 3. Since we are given the point, let's find derivative at x equals to 1. So basically substitute 1 here. When you substitute 1, you get 2 minus 3 times 7 minus 3 plus 1 minus 3 minus 2 times minus 3, correct? So that gives you minus 1 times 4, 7 minus 3 plus 1, this is minus 4 times minus 3, or we have minus 4, minus minus makes it plus 12, and that is indeed plus 8. So the slope at x equals to 1 is 8. So we can write m equals to 8. And we know the point, which is 1, 8, correct? Knowing slope and the point, we can always write the equation of the line. So let the equation of the line be y equals to mx plus b. So we can substitute these values. Y is 8 equals to slope of 8 times 1 plus b. And that gives you 8 minus 8 equals to 0, right? Which is the value of b, right? Therefore, the equation of the line is y equals to the slope 8 times x. And you can see 1 times 8 is 8, so that also works. So that becomes our answer. So the answer is, equation of the line is y equals to 8x. Perfect. Now let's move on to the next question, which is the last question of this set of 4. The question here is, at what point on the curve y equals to x to the power of 4 does the normal have a slope of 16? So we are given curve y equals to x to the power of 4, and we are also given slope of normal. So slope of normal equals to 16. So what is slope of tangent? It should be negative reciprocal, right? So it is minus 1 over 16. That is important to work out. Now it is simple. At what point on this curve does the normal have a slope of 16, or the tangent has a slope of minus 1 over 16, correct? So let's find the slope of the tangent. So slope of the tangent m is the derivative of this function, which is 4x cubed. And we are given this value as minus 1 over 16. So we have minus 1 over 16 equals to 4x cubed. So we could write this as minus 1 over, this is 48, 16 times 4, right, equals to x cubed. And from here, clearly, what is x? So x is equals to cube root of minus 1 over. 16 is also 4, right? 4 times 4. We have this number here. And clearly the value of x is minus 1 over 4, correct? So we get the point x. At what point we need to find y value also, right? So x is this. Y will be x to the power of 4, which is minus 1 over 4 to the power of 4, correct? Which is definitely a positive value. So a positive value 1 over 4 to the power of 4 or 2 to the power of 8, whatever. So we could just multiply this and then write, correct? So you can say 16 squared, 256. Correct? So that becomes the y value. And therefore the point is x value of minus 1 over 4 and y value of 1 over 256. Perfect. So I hope with this series you learn how to find equations of tangents when different conditions are given to us, how to find point on the curve when slope of the tangent is given to us, and likewise. Feel free to make your suggestions, post questions, and if you like and subscribe, that'd be great. Thank you and all the best.